In our previous lesson, we were working on how to solve rational equations and came up with 5 general guidelines to follow. We said the first thing we want to look at are the denominators and make sure they're in factored form. Because once they are, we can find our lowest common denominator. We know rational equations are equations that are adding and subtracting fractions, so we have to have that common denominator. Well, once we find that common denominator, if we multiply each term by the common denominator, that will undo the division for the fraction, and then we can perform the operations like we normally would do to solve for the variable involved. As always, we have to check our solutions to see if they are extraneous or not. So we're going to look at some examples in your Unit 5, Day 19 notes, and see if we can apply those principles to it to help us solve. So here's our first rational equation. And again, like we said before, we want to look at the denominators and make sure they're in factored form. So our first denominator of x plus 2, that's already in factored form, so we don't have to worry about that. The second denominator, x squared plus 2x, we can see they have an x in each term, so we could divide that out. So we have x times x plus 2. So again, trying to find the common denominator. So we want them to match. Our first term has an x plus 2, which means our second term needs an x plus 2, and it does. This term here has an x, this one does not. It would need an x. So our lowest common denominator would be x times x plus 2. We're going to take each piece of our equation and multiply it by that common denominator to undo the division that was occurring. And so we know, again, with our fractions, we multiply across. So we would have, this is our next step, we've got a negative 1x times x plus 2 over x plus 2 equals 2x times x plus 2 over x times x plus 2. So after we've done the multiplication, again, we're going to look to see, do we have any like terms we can divide out from the numerators and the denominators. So here we can see we could divide out an x plus 2. Here we can divide out an x and an x plus 2. So we'd be left with negative x equals 2. Well, to get x by itself, we would have to divide each side by negative 1. Therefore, x equals negative 2. Now that we've solved for x, we have to substitute its value into the original equation to make sure that it's not an extraneous solution. So we substitute our value for x and simplify according to our order of operations. You can see on the left-hand side we've got negative 1 divided by 0 equals 2 over 0. Well, we can see that they're not balanced, and also we know that we cannot take something and put it into 0 groups. Therefore, this would be an extraneous solution. It's giving us an undefined scenario, which cannot happen. So x equals negative 2 cannot work. So we're going to say no solution. Let's take a look at another rational equation. Again, we want to follow our guidelines by looking at the denominators and making sure they're in factored form. So our first denominator, x minus 6, that's factored. Our second denominator, x minus 2, is factored. Our third denominator, x squared minus 8x plus 12, we have to see if we can factor this. It is a quadratic, so again, we look to see, is there a greatest common factor other than 1 that we could divide out? No. So we'll take that leading coefficient times the constant. What times what gives us 12? And what plus what equals negative 8. We know the numbers that would make both of those items true would be a negative 6 and a negative 2. So we're going to put this into our factored form. And again, now that the denominators are factored, we want to make sure what's our lowest common denominator. So I need an x minus 6, I need an x minus 2, and this has both of those, so we're okay. So our lowest common denominator is going to be x minus 2 times x minus 6. So we're going to take that common denominator and multiply every term in the equation by it. So again, when multiplying fractions, you multiply across for every single term. Again, we're looking to see what can we divide out that's an exact match from the numerator and denominator. So our first term here, we could divide out an x minus 6. Our second term, we could divide out an x minus 2. And our last term here, we could divide out an x minus 6 as well as an x minus 2. So that would leave us with x minus 2 plus x times x minus 6 equaling 4. So at this point, we're going to just perform the operations like we normally do to solve for x. So we would distribute the x to the x minus 6, combine any like terms that we can on the left-hand side, and try to write it in standard form because we can see it's to the second degree, so it's a quadratic, so we want to see the quadratic, the linear, and the constant. Now that the left-hand side of the equation is simplified, we can start working on solving the quadratic equation. And we know whenever we're solving quadratic equations, it must equal 0 to start. So in order to do that, we can subtract 4 from each side of the equation. So now we have x squared minus 5x minus 6 equals 0. We've worked on solving quadratic equations in the past, and we have multiple ways to do that algebraically. This quadratic equation is not one that we can undo because you have that quadratic and linear term. So you could see if you could factor this, use the quadratic formula, or perhaps you'd like to complete the square. We said probably you want to see if you can factor it first because that's typically faster than the formula in completing the square. So again, take that look to see if you have a greatest common factor other than 1 to divide out, and that's not happening here. Take the leading coefficient times the constant, so what times what gives us negative 6, and what plus what would give us a negative 5. So if we think of the values that will work for both of those number patterns, positive 1 and negative 6 will work. So we can factor this using those values. And again, if you like writing it as 4 terms, you can. So we could write it as x squared plus x minus 6x minus 6. Look at in groups where you could factor it. The first pair we could divide out an x. A second pair we could divide out the negative 6. There we can see they have a common factor of x plus 1, which is being multiplied by x and a negative 6. So those are the two factors for the equation. Again, if you can go from the quadratic equation to the factored form without doing the steps in between, that's fine and you're good to go. Now remember, this is not solved yet. We are multiplying these two items to end up with an answer of 0. That means one of those two items must equal 0. So we have to set each one equal to 0 and see what values for x make that true. Well, if x plus 1 equals 0, the value of x that makes that true is negative 1. And if x minus 6 equals 0, the value of x that makes that true is 6. Again, we have to check and see if both of these values for x are true for the equation, or if not, they're extraneous solutions. So we have to test each one to see if they work or not. So if we start with the 6, again, substitute the values for x into the original equation and simplify to see what we're working with according to your order of operations. Well, we can see that the first term here will have a 0 in the denominator, and that's undefined. So that's not going to give us a balanced equation. Therefore, we know that x equaling 6 cannot be a solution to the equation. Now, if we check our other value for x, which was the negative 1, we can see that all the values for the denominators are defined, and it checks out. So when we add these two values together, it will equal this value. So x equals negative 1 is a solution to our rational equation. Let's take a look at another scenario. Minnie plays tennis frequently. To date, Minnie has won 12 out of 20 matches. How many consecutive matches will Minnie have to win in order to improve her winning percentage to 75%? Whenever we're presenting with scenarios, again, we should ask ourselves, what do we know? Right now we know Minnie has won 12 out of 20 matches. Well, by winning 12 out of 20 matches, what percentage is that? Well, that would be 60%. So she wants to improve her winning percentage to 75%. So if she's going to win more matches, that means she's playing more matches. So as she plays, the total number of games she plays will increase, as well as the total number of winnings, hopefully, should also increase. Well, to show how we could represent that, we're going to be adding games to the 12 and the 20, and we want to end up with a 75% win rate. So again, here's how we're playing the games, how we want to add to the winnings, hopefully, but you're always adding to the total. And then this is the percentage that we want to end up with. Well, as we look at the equation, I know I could simplify 75 out of 100 right off the bat to 3/4. And so that will help me work with my equation in some smaller values. So again, we've got to figure out how many games she has to win in order to improve her percentage. So again, we want to look at the denominators and ask ourselves, are they factored? So here we've got 20 plus x, if you want to think about it as x plus 20. That's in factored form, no other factors besides a greatest common factor of 1. And then 4 as well, that's already factored. So our lowest common denominator would be 4 times 20 plus x. Just like we did before, we'll multiply each side of the equation by 4 times 20 plus x. And again, remember, we multiply fractions across. And again, at this point, after we've multiplied across, you're looking to see what do they have in common you can divide out that are exact matches in the numerator and the denominator. So here on the left-hand side, we could see we could divide out the 20 plus x. So we'd be left with 4 times 12 plus x. On the right-hand side, we could see we can divide out the 4. So we would be left with 3 times 20 plus x. At this point, we're just going to perform our operations like we normally do to solve for x in the equation. So that means on the left, distributing 4 to your 12 plus x. On the right, distributing 3 to the 20 plus x. That would give us 48 plus 4x equals 60 plus 3x. And again, at this point, we want to combine our like terms to solve for x. That means putting the variables on one side and our constants on the other. And we typically suggest starting with the lowest variable, so that would be 3x. Since we were adding 3x, we could subtract 3x from each side, which means we've got 48 plus x equals 60. Then that means we would subtract 48 from each side, which means x equals 12. Again, we want to check and make sure, does this make sense for our scenario? So we're going to substitute 12 back into our original equation and see what happens. So again, simplifying according to our order of operations, we're going to have on the left-hand side 24 32nds equals 75 100ths. Well, I'm going to say, well, can we simplify each side? We already know that 75 100ths is 3/4. Is there anything we could divide out from both 24 and 32 to check that? And we can divide on 8 from each of those. And so then we're left with 3/4 equals 3/4. That's a true statement, so x can equal 12. That means Minnie has to win 12 more matches to improve her winning percentage to 75%. Well, what if Minnie wants to improve her winning percentage to 90%? How many consecutive matches will she have to win in order to do so? Well, we know Minnie has won 12 out of 20 matches, and she's going to keep playing more games to add to her total and add to her winnings. And we want it to be 90%, and 90% is 90 out of 100. So we could set up an equation to model that scenario. Again, we can simplify the 90 out of 100 to 9/10 to work with some smaller values. And again, with our rational equation, we want to ask ourselves, is the denominators factored for the equation? And we'll double check and see. Nothing other than a greatest common factor of 1 can be done here, so we'll leave it as is. And 10 is already in our factored form. So again, we want to find our lowest common denominator. So we know we'll need a 10 and a 20 plus x. So that would be what we're going to multiply our equation by. Again, we multiply across to both sides of the equation. And again, at this point, we're looking to see what like terms can we divide out from the numerator and denominator on each side of the equation. So on the left-hand side, we could divide out a 20 plus x, which would leave us with 10 times 12 plus x. On the right-hand side, we could divide out a 10, which would leave us with a 9 times 20 plus x. Here, we can just perform our operations like we normally would to solve for x. So we're going to distribute the 10 times 12 plus x and the 9 times 20 plus x. And again, when we're solving our equations, we try to typically start with our lowest variable and start combining. So since we were adding 9, we could subtract 9 from each side, which would leave us with 120 plus x equals 180. Then we're going to combine our constants, so we could subtract 120 from each side. So that means x equals 60. Again, we're going to check and make sure that 60 really does work for our equation. So if we can substitute it in, we can see that the denominators are going to be defined. Let's just make sure that it's balanced. So again, we know 90 out of 100 is 9/10. Again, looking at 72 over 80, is there something that we could divide out from each of those to simplify it? And we could divide out an 8, which would leave us with 9/10. Both of those are balanced, so therefore we know that 60 works. So therefore Minnie would have to win 60 matches in order to improve her winning percentage to 90%.